In the preceding example, we demonstrated some string concatenation with the plus operator, and for the first time, we talked about an implicit conversion that occurred. We took a double value and added it to a string literal, which caused the double value to be converted to a string, and then the two strings were concatenated via the plus operator. There are other implicit conversions that can be performed in C# as well between the simple types. So what you see here on the screen is a list of all of the simple types in C#. And going top to bottom through this list, I'm showing you not only the names of the simple types down the left-hand side here, but all of the conversions that are allowed from a given type to other simple types in C#. So for example, at the top here we have the bool type, which represents a true or false value, and there are no implicit conversions between bool and the other simple types. So this is different, for example, from C and C++, where in those languages not only do you have a type for representing true-false values, but you also have the ability to represent true and false as numeric values, for example, where 0 is false and anything else is true, or as in C and C++ in particular, pointer values, where a pointer to a chunk of memory is considered true and the value 0 or null is considered false. But in C#, bool is bool. There are no conversions between bool and the other simple types. You can, of course, convert a bool to a string, which you saw in our logical operators example a couple of lessons ago, and in that case, you get the string true or the string false with a capital first letter in each case. The byte data type, which represents a single byte of information, any byte value can be converted to all of the different types that you see here to the right of the long dash. So we haven't talked about these before, but U short represents an unsigned short integer. A short integer is 2 bytes of memory, and an unsigned short integer is also 2 bytes, but it can represent only values from 0 and higher in those 2 bytes of information. So the short type is like ushort, but allows you to represent both a negative and a positive range. The unsigned version of a given type represents approximately twice the positive range, and of course no negative range for an unsigned type. We also have uint and int, ulong and long. An int is 4 bytes, a long is 8 bytes, and then of course we have the floating point types that we've talked about previously, decimal, float, and double as well. So a byte can be converted to any of those types. A char is a 2-byte piece of information that's specifically used to represent a character in the machine's character set. So characters are actually integer-based types and can be converted to all of these other types as well. Decimals do not have any implicit conversions, and the reason for that is if you convert a decimal to any of the other types, all of which are smaller than decimal, there is the possibility for losing information. Anytime there's a chance of losing information, no implicit conversions are allowed. Only explicit conversions are allowed with so-called cast operators, like we introduced in an earlier lesson. Type double also has no implicit conversions to the other simple types. Floats can be represented as doubles, so any float value can be converted to a double, but not vice versa. And the reason for that is a double uses twice as much memory, so it has higher precision overall. So converting down from a double to a float, which is from 8 bytes to 4 bytes of information, implicitly is going to lose information. And again, because of that, you can only go from the smaller type float to the larger type double. Integers can be converted to longs, decimals, floats, or doubles. Longs can only be converted, on the other hand, to decimals, floats, or doubles, and that's because, again, there's not a loss of information there when you go from long to those other types. We also have S-byte for a signed byte of information. So byte by default is an unsigned piece, but sbyte is a signed byte of information, and it can be converted to all of these signed data types. Then we have short for a 2-byte integer, which can be converted to these types, uint for an unsigned 4-byte integer, ulong for an unsigned 8-byte integer, and ushort for an unsigned 2-byte integer. Now, in general, implicit conversions should be avoided so that you don't get logic errors in your program, but these implicit conversions will come into play, for example, if you pass a value of one of these types into a parameter of a different allowed implicit conversion type. So for example, if I pass an int where a long decimal, float, or double is expected, the compiler will be perfectly happy with that, and it will produce a corresponding value of the appropriate type, which is a copy of the original integer value in memory. Similarly, if I take a value of a type such as double and pass it where an int is expected, no implicit conversions are allowed for type double. In that case, the compiler is going to generate an error for me, and that will help me eliminate potential problems at compile time.